Yeah, very good evening to all. So in the previous class, we have discussed about method of integration applications, and just I want to continue the same portion. So today, I would like to just calculate the center of mass of a semicircular ring. This is very, very important throughout the topic, because if you know the just center of mass of a semicircular ring, we can just find out the center of mass of different bodies also by using the center of mass of semicircular ring. So this is very, very important. Semicircular ring. Semicircular ring. So if it is circular ring, the center of mass must be coincide with the geometric center of the ring. But this is not a complete ring. This is a semicircular ring, means the center of mass must be changed with respect to coordinates. With respect to coordinates. So now coming to the point now. Now this is a semicircular ring. Just have to assume. Now, so the symmetry of the semicircular ring equals to, just I want to just assume this is the line of symmetry. Symmetry of the given figure. This is the line of symmetry. Symmetry, method of symmetry. By using method of symmetry, just what is the dividing part? This is the dividing part of this total semicircular ring. Now just half radius of this semicircular ring equal to R. This is the R is nothing but the radius of the semicircular ring. Just I want to consider this is origin. Let it become this is origin. Now here try to understand one important point. Where is the center of mass located of given semicircular ring? Now just my concern here, let it be considered as this is a origin. This is a origin. Just I wish to just find out the just center of mass of the semicircular ring with respect to this point. I said already the total mass of the semicircular ring equal to capital M. Total mass of the semicircular ring equal to capital M. And coming to the next one, very, very important. So along, if you are consider this point, what is the center of mass of this point? So whenever you are going to calculate the center of mass of any body, first of all, also I want to just fix where it is on the x-axis. Let it be on this x-axis. This is automatically y-axis. This is automatically y-axis. Now coming to the point now. So on the x-axis, if I just fix this point, what about the XCM? Students, please respond. What about XCM? XCM must equal to 0. XCM must equal to 0. Because this is a fixed point. Am I right? Now coming to the next one. Just what is the second point? Assume, just consider elemental mass on the surface of the circular ring. Circular ring. I just consider this is a elemental mass. This is the elemental mass. So let it be considered this is the elemental mass. I just consider dm. This is dm. Right? Now just I consider the angle. This is the angle. So what is the angle made with the x-axis? I considered again, this is pi. Pi is the angle with the x-axis. This is x component or x coordinate. This is y coordinate. Okay. This is nothing but a radius. Radius of the semicircular ring. Radius of the semicircular ring. What is the width of this one actually? What is the width of this one? This is width of this one. So what is width equal to here? Width equal to like d pi. Width equal to like d pi. Now here comes to the point now. What is d pi? d pi is nothing but width of semicircular ring. Width of semicircular ring. Now here dm is the mass of elemental mass of the semicircular ring, and d pi is the width of this ring. Right? Very good. Now come to the point now. What is the radius of this one? R. Just consider R. R is the radius of this given part. Otherwise, this is also radius. Automatically, this one also equals to radius. And one more point. Now coming to the next one. So what about this one? What about this one? This is also x-axis. This is also x-axis. If it is pi, what about this value? What about this value? This value also equals to pi. This is also equals to pi. Now try to understand this terminology. Now here, what is pi? Pi is the angle made with x-axis. Angle made with x-axis. And coming to the next one. This is the width of the given ring. So let it be considered d pi. So this is pi automatically also pi. This is the terminology. And coming to the next one, this is the y component actually. This is y value. Y direction. So this is the y represents like radius, otherwise just y component. Like this is the diagrammatical representation of a semicircular ring. First of all, try to understand the terminology from the semicircular ring. Okay, coming to the point now. So how to calculate the center of mass of the semicircular ring? What are the formulas? We discussed yesterday clearly. YCM equal to, yes, I want to calculate the YCM value along the axiom. Mute yourself. Yes. Mute yourself. Hello, students. Yeah, okay, please. Now here, how can we calculate the YCM value? YCM value. What is the formula for the YCM? YCM equal to
1 by
integration of
x
y dm by integration of dm. This is the formula. Because of here xcm equal to all xm equal to 0. So then what is the next step? You need to go for the just YCM value. YCM equal to integration of y into dm by integration of dm. Integration of dm. Okay. Now come to the point now. So simply we can write what is dm value. I want to just find out the dm value. This is very important step. So how can you calculate dm value? dm is equals to dm equal to, how can you calculate the dm value? So now dm is equals to, what is the total mass of the circular ring? Circular ring, capital M. Total mass of the circular ring equal to capital M. Now try to understand one more important point here. How the d pi value varies. Now come to the point now. If the body is at here, the body is at here. Let it be like this is the origin, like origin 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 135, and so on, just to up to what angle just possible? Pi angle up to here. What is the
1
half of the circle? Pi angle. So for unit angle, what is the angle actually here? Pi angle. Okay, now how much the just angle is there? D pi. Now try to understand. For unit angle, what is the dm value? Dm equals to total mass by what is the possibility of the just given angle? Pi from 0 to pi in what is the angle? D pi. Now coming to the point now. So what is the pi value? How can you calculate the pi value? How can you calculate the pi value? Now if you are considering just a sin pi value from the given diagram. Sin pi value. What is the sin pi value? Sin pi equals to opposite by hypotenuse. Sin pi equal to opposite. What is the opposite value? Y by
d pi
hypotenuse. R. Is it okay? Sin pi equals to y by r. So therefore, what about y value? Therefore, y is equals to r sin pi. R sin pi. Please up to here, right? Please. This is the y value. So we got it
Can
y
you
value.
explain again?
Yeah.
Can you explain again?
Yeah. I will explain once again. So up to here, please write down. Okay. Students, please write down this information. Again, I will explain what I just explained up to here. Can I continue? Yeah, please. Once again, please try to understand. So this is a semicircular ring. This is not a complete ring. Half of the part of the just a ring, semicircular ring. That means. So now, how can you calculate the center of mass of semicircular ring? How can we calculate it? Assume just the radius of the semicircular ring is equal to r, right? So along the x-axis, I want to just fix the one point. So at this point, center of mass of the given point equal to 0 because of this is a fixed point. Center of mass does not change means automatically that must be equal to 0. I said already that means. Okay. Now in this case, xcm equal to 0 because of this is along the x-axis. So at this point, xcm must be equal to 0 because of center of mass does not change along this path. So automatically the center of mass must lie in the y-axis. So somewhere actually. Now here try to understand. If I connect the just this is a dm. Dm means elemental mass on the circumference of the circle. Dm is a elemental mass. Just assume elemental mass for the circumference of the circle. Now here this is a r distance. So this is like a radius, otherwise position vector like. So this radius made with the x-axis, what is the angle? Pi. Pi is the angle, theta or pi or some angles. Now I just represented as pi. And coming to the next one, again I just connect the one more just position vector to the just dm. So here this is a width of the circular ring. Now try to understand d pi is nothing but width of write down the terminology, width of circular ring, width of circular ring, width of circular. Already we know the just dm value. Dm means elemental mass of circular ring. Circular ring. Now try to understand. So this is the pi value. Automatically this one also equal to pi. Right? So this is the radius vector. Let it be considered as R, capital R. Now just according to just given diagram, we are going to calculate the YCM value because of XM already 0. YCM equal to integration of y into dm by integration of dm. Integration of dm. So I need just now try to understand this point. So first you have to convert into similar terms. If you have just more variables, the calculation should be very difficult. Am I right? Now come to the point now. Integration of y into dm by integration of dm. Already we discussed these formulas previously. So now here y into dm. First of all, I just calculate the dm value. How to calculate dm value? This is a circular ring. This is a circular ring. I said already. D pi value varies from 0 to pi. 0 to pi. So consider this is 0, 30, 45, 60, 90, 135, 80 like that. If you are just just move the particle position. Automatically the angle also must be changes from 0 to 180. This is very, very important point. Here d pi value varies from 0 to pi, 0 to pi. So then just based on that point, just I want to calculate the dm value. Dm equals to, therefore dm equal to total mass of the circular ring. Semicircular ring equal to capital M by per unit angle. Per unit angle means what is the angle possibility from the semicircle? Pi. Into what is the total angle? D pi. The total angle is just for this dm. What is the angle actually? D pi. This is the d pi dm value. And coming to the next one. So we got the dm value, and just I want to find out the y value. Y value because of just I want to convert it into similar terms. Similar terms. So now according to given diagram, this is a triangle. This is a triangle. According to sine theta or sine pi. Sine pi equal to opposite side by hypotenuse. Hypotenuse. Okay. Now opposite y by hypotenuse equal to r. Simply just I want to just calculate the y value in terms of r. So y equals to r into sine pi. So we got it just y and also dm value. Both we got it. Directly substitute in the given expression. Directly substitute. So finally what you will get? I want to calculate out. So therefore ycm equal to integration of, now try to understand. Integration of dm is nothing but capital M. So I want to write just capital M directly. 1 by M. So integration of y. Y is equals to r sin pi into whatever dm value equals to this one. M by pi into d pi. So what are the limits here? What are the limits possible from 0 to pi? I said already. What is the phase angle? What is the phase angle here? From 0 to pi. So simply we can substitute 0 to pi. 0 to pi. Okay. These are the limits. Lower limit equal to 0 and coming to the just upper limit equal to pi. Upper limit equal to pi. Simplify this value. Students, are you following? Hello?
Yes.
Student? Yeah. Now here mm get cancelled. Here mm get cancelled. Yeah, okay? Get cancelled. What are the remaining possibility? R by pi, take separate. R by pi integration of 0 to pi. So sin pi into d pi. So this is very, very important concept. Just to pay the concentration because of just you can feel just a little bit difficult. Try to understand this information, please. Pay the attention clearly. Now here r by pi into integration of sin pi into d pi. Now tell me what is the integration of sin pi? Integration of sin pi.
Cos pi.
Cos pi, is it correct? Cos pi minus cos pi.
Minus cos pi.
Now here r by pi into minus cos pi. What are the limits? From 0 to pi. 0 to pi. Right? Now just I want to find out. R by pi into upper limit minus lower limit minus cos pi minus of minus plus cos 0. Cos 0. Right? So simplify this value. R by pi minus cos pi. What is the value for cos pi?
Minus
Cos pi. Cos pi equal to minus 1. Am I right? Cos pi equal to just minus sign outside. So 1 plus 1. Cos 0 equal 1. Okay. So what is the answer? 2r by pi. 2r by pi. YCM equal how much it is? 2r by pi.
Sir,
Write
why
up,
did
please.
you erase the minus, sir?
Take separate minus. Okay, otherwise, so anyone you have to follow, no problem. If you consider an integration answer, finally just a minus of minus, will get the final answer. So what is the YCM value?
Sir, how did you get R by pi, sir?
R by
Pi. How did you get R by pi, sir?
R and pi both are constants. I just taken separate.
Okay, sir.
Okay.
Sir,
Yeah.
how did you get minus cos?
Minus integration of sin pi minus cos pi.
Sir,
Okay.
minus cos no you written plus or
Just directly have to substitute. You will get the same answer also. You will get the same answer, no problem at all. Take separate this one, no problem. Otherwise, just to directly have to substitute. You get the same answer. Minus cos on pi. What you will get? 1. Minus of this one actual minus. Again, you will get the minus. Minus of minus plus 1. So 2 into r by pi. 2r by pi.
sir, why you written
That
1
is
by
simple
m
question.
first?
Excuse me?
Sir, why you written 1 by m?
Why you written 1 by? Where? This one.
YCM is
Okay.
equal to.
Yeah, okay. So integration of dm equal how much it is? Total mass of the just given a semicircular ring. That is capital M. So if you are adding just small m1 plus m2 plus m and so on, just it is equals to capital M. Directly, I just have written.
Sir, sir, but in linear density, you not took M, no, sir.
This is not linear density.
Okay,
This is not linear density. For unity angle, how much just elemental mass develop? This is not linear density. Okay.
okay, sir.
If it is linear density, we can write m by L. But this is not a linear density. So for unit angle, how much just elemental mass developed with respect to d pi value? In d pi, how much just elemental mass developed? Capital M by total mass by what is the phase angle? Pi. Okay.
Okay, sir.
Yeah, please. Now here very important point is dm value, how to calculate the dm value, and coming to the next one, y value. If you know these two values, directly we can substitute, then go for the calculation. So one more point is here, integration of sin pi d pi. What is the answer? Minus cos pi. So this is related to just a calculation, no problem. Is it okay? So all of you getting my point?
Yes.
Yeah, okay. Can I rub this one?
Sir, YCM value, how did you get?
So this is YCM. This is also YCM. So finally, what is the answer? Can I rub this one? So finally, this is the YCM. So YCM equal to where is the just YCM value? Therefore, I want to give the just analysis of YCM equals to 2r by pi. So 2r by pi is nothing but on the y-axis, where is the center of mass is located? At the height of 2r by pi. Just I want to give the just diagrammatical representation. Can I have this one?
Yes, sir.
Yeah, okay, please try to understand. Now, if you are considered this is a semicircular ring. Semicircular ring. So where is the just a center of mass located on the y-axis? Just you have to assume like 2r by pi. So totally this one actually. So this is the 2r by pi. Let it be considered this is a 2r by pi. Right? This is 2r by pi. So this is the height along the just y-axis. Height along the y-axis. So this is the center of mass of given semicircular ring. Where is the center of mass located on the semicircular ring? At the height of how much it is?
2r by
Height. The center of mass is located. Okay, that is the generalization point from this mathematical notation. Should be clear. So this is very important to establish the remaining like semicircular disc, triangular lamina, hollow cone, solid hemisphere, whatever it may be. So this is the ultimate derivation or formula. Remember directly this formula also. What is the center of mass of semicircular ring? Directly have to remember 2r by pi. Just I want to utilize the same value to establish the next one also. Should be clear?
Yes, sir.
Yeah. Any doubt in this area? This is very important. If you have any doubt, please try ask the doubt. Yeah.
The YCM value is written 1 by m, that integration.
Hmm. Hmm. So YCM equal to this is YCM equal to what is your doubt? Why did you just write 1 by m? Is it your doubt?
No, sir, the total value, how did you got?
Total value. This is actually total value from 0 to pi. This is 0 to pi actually. So that's why just I applied a just integration. So what is the meaning of integration? The total value of the given summation actually. I said already. I considered elemental mass, but I applied the just integration of the given elemental mass. So finally, what you will get? Finally, what you will get? 2r by 5. 2r by 5 is the YCM of semicircular ring. That is the ultimate or total value. Okay.
Okay, sir.
Actually, I considered elemental mass. Is it okay? Finally, what I applied actually integration. So when I applied the just integration part of the given elemental part, so what you will get finally, that is the just center of mass of the given circular ring, semicircular ring. That is the final answer. Okay. So you don't bother about just that is not the individual value. That is the final value of the just semicircular ring center of mass. Where is the center of mass of the semicircular ring? Where is the center of mass of semicircular ring? So located at a height of how much it is?
2r by 5.
By pi. That is the answer for the given value. So this is very important. So try to understand the given integration of this method. Okay.
Okay, sir.
Next, one more example. Can I?
Sir,
Yeah.
so how do you get value of dm equal to m by pi d?
Yeah. Once again I will explain. Please try to understand. In semicircular ring, we are talking about angle. Will you agree? Now here, with respect to angle, just I want to find out the elemental mass value. So that's why try to understand this point. So here also I said one point. So angle, what is angle actually? D pi. D pi is nothing but width of the semicircular ring. Now the semicircular ring angle starts from 0 to pi because of this is semicircular ring 0 to pi. So simply remember pi value starts from 0 and ends with pi. So that means 0 to pi. Pi value varies from 0 to pi. Is it okay? Now try to understand. Now dm value, how can we calculate the dm value? So now dm just completely depends on the angle. dm completely depends on the angle. Now, so dm is equals to total mass of the semicircular ring equal to capital M. Students, please try to understand this point. For unit length, what is the mass? M by L. For unit area, what is the total mass? M by A into some dA. For unit angle, now try to understand. For unit angle, what is the angle? That means we can write simply dm is equals to total mass of the given body by per unit area means what is the just angle here per unit angle pi into again you have to develop the angle. What is the angle? D pi. For example, just leave this content for unit length. For example, m by unit length L. If it is unit length L into what we have done actually dx. Previously I done this model. For example, unit area into just area. Try to understand these points. So based on the situation, if it is the angle, so finally we will get the angles. If it is length, finally we will get the length. If it is area, finally we will get the areas. This is approach to calculate the elemental mass for the different bodies. Maximum just I want to just use these three notations. Okay, got it. So here, how can we calculate the dm value per unit angle? How much elemental mass developed from the circular ring? Students, okay? So here very important terminologies per unit angle, per unit length, per unit area. These are the important terminology to find out the just elemental mass, right?
Yes, sir.
Next, coming to the next one. Just work out the problem. So you will get the answer, idea. Next, coming to the next one. Semicircular disc. Next one is a semicircular disc. Semicircular disc. Again, you have to practice thoroughly, please. So yesterday I given just two important areas. Today just I want to give you some important areas. Semicircular disc. Now try to understand here. Very important point is there. So if you don't know the integration of sine pi, please add that point also. Integration of sine theta. Integration of sine theta equal to minus cos theta. If you don't know, please add that point also. Previously I said refer integration formulas. If you know the integration clearly, we can understand very easily this information. Next, semicircular disc. Now here very important points are there. So what is the difference between a ring, semicircular ring and a semicircular disc? This is very important. So what is the difference between a semicircular ring and a semicircular disc? Okay. Ring means where is the mass located on the ring? Please respond. Interact with me, please. Where is the mass located on the ring? And just compare with the disc also.
Middle.
4 by pi.
No, I'm asking where is the mass located?
The center of mass.
Now
Center of
understand my question. So
On the
where is the mass located in the ring?
in the center of the in the center
Am I
of
right?
the ring.
In the center. Just so according to just your answer, just the mass completely located at this point actually. Is it correct?
Yes, sir.
No. Here on a circular ring, the total mass located on the surface of the ring. That is very important. So this is the mass located point. Very important. Okay. So from a circular ring, I'm talking about that circular ring mass. From a circular ring, the total mass, the overall mass located or enveloped on the surface of the ring. This is a very important point. And what about disc? And what about this? Try to answer it, please. What about disc?
It is located in the. It's not located in the surface of the disc.
Where it is actually?
Inside the.
Inside.
Outside, in the surrounding of the disc.
Total mass occupies throughout the disc actually. Now here, when you observe the disc, for example, I want to consider the disc. the structure of the disc. This is also structure of the disc. So where is the mass located in the disc actually? So from the disc, the mass occupies throughout the disc. So this is the total mass. This is the total mass. So not on just envelope on the just disc. So when you observe the disc, just sometimes just you are playing with some different instruments actually. So from the disc, where is the mass located throughout the material, not on the surface of the material. So that is the key difference between the circular ring and disc. So once again, just I want to just repeat this, repeat the same point. On the circular ring, the mass is located on the surface of the circular ring. Come to the just disc. Come to the disc. Where is the mass located? The mass completely occupies throughout the disc. So wherever just you observe the just disc, the mass is just occupies. So that is the main difference between the circular ring and disc, right?
But then there is no center of mass for disc.
So center of mass established actually, but exactly not located at the geometric center. That is the main point. Because of this is a semicircular disc, not a complete disc. If it is complete disc, the mass, the center of mass exactly located at its geometric center, but this is semicircular disc. So if it is semicircular disc, maybe just on the y-axis, I thought. Should be clear. Can we find out?
Yes, sir.
Yeah, okay, please. Now this is a disc. So I said already one important point. If you know the center of mass of a semicircular ring, okay, we can establish the center of mass of a semicircular disc also. Very, very important. Very, very important. Try to understand this one, please. Now here, this is a x-axis. This is x-axis. Okay, right? So first step, first you have to choose the symmetry of the given body. So now here, this is the symmetry. Symmetry means divided into two equal parts. Yeah, exactly. Divided into equal parts. If I just consider this point, if I just confirm this point. So what about XCM value?
0.
0.
Exactly, 0. So here just the HCM must be equal to 0 because of center of mass does not change around this point. So I just because of I fixed this point. Simply XCM equal to XCM equal to 0. And coming to the next, this is 0. I consider this is R, radius of the disc equal to R. Right? And this is also radius. Okay, because this is also radius. The total mass of the disc is equals to, again I considered M without any confusion, just I considered capital M. I said already one point. So how can we find out the center of mass of the disc? I am just going to utilize the circular ring. Circular ring. I just want to consider the circular ring here. This is a circular ring. Just assume circular ring. If you are just joining circular rings, all you are considered the circular rings, what will get? Finally, it acts as a disc. If you are taking just this is a circular ring, this is a circular ring, this is a circular ring, this is a circular ring. So what is finally you get? Disc. That is called disc. So that's why just I want to consider circular with respect to circular disc. Sorry, circular ring. Just I want to find out the center of mass of semicircular disc. Don't confuse this point. So I have just one important notation. What is the notation actually? Center of mass of circular ring. I'm just going to utilize that information. Just I want to find out the center of mass of the circular disc. Are you okay? Now here, this is a circular ring. This is a circular ring. Now this is this is circular ring radius. Like I'm just consider Y. Y is a circular ring radius. Y. Right? And coming to the next one. Now this is a Now this is a semicircular ring. Am I right? This is semicircular ring. This part. Is it clear? This part. Just I'm just highlight this part. This is this green surface. This is a semicircular ring. Semicircular ring. Semicircular ring. Right? And coming to the next one. What about this one? Just to have to assume. This is dy. I consider dy. What does the dy means? Like width. Width of the semicircular ring equal to, I considered dy. Here dy is nothing but width of the semicircular ring. Don't confuse, please. So my concentration is completely on semicircular ring. If I just consider the semicircular ring values, automatically I want to consider the disk values also. Now coming to the next one. So what about this one? dm. This is dm value. This is the dm. What about dm value? dm is nothing but mass of ring. This is mass of ring. Ring mass otherwise. Mass of ring. Please draw the diagram very clearly with clarity. Not any confused, please ask me clearly. Now here, this is, I consider this is circular ring. Why do we consider circular ring? What is the point here? What is the important?
This disk.
If you consider the just number of circular rings from just origin to just surface, so one in what you will get? Circular disk. Yeah, exactly. So that's why I considered circular ring from this point. Right? So this is dm. dm is nothing but a ring mass or mass of circular ring. Mass of circular ring. Don't confuse. Mass of circular ring. Should be clear? Have any doubts? Okay, now
No,
what is the mass of circular ring? Yeah? Any doubt?
No, sure.
Yeah, very good. Please draw the diagram clearly. So now, just what you have to find out? YCM is equals to, what is the common formula? YCM equal to integration of y into dm whole divided by integration of dm. So this is the ultimate formula. Students, here identify just one important notation, one important point. Whenever you have to develop the any mathematical approach, first you should convert into similar terms. That is very important. Otherwise, if you have a number of variables, the calculation should be very difficult. Is it okay? So that's why let's try to understand. For example, integration of x into dx. These are similar terms.
X square by 2.
Integration of y into dy. These are similar terms. If it is similar terms, the solution should be very easy. For example, this is x. This is y. What happens? These two are two different variables. These two are two different variables. If these two are two different variables means the calculation should be very difficult. Very difficult. Okay. So that's why first of all you have to convert it into similar terms. So whether it is just x or y, that is not a matter. Okay. So that's why just I want to convert it into the similar terms. Right? So here, what are the main variables here? dm value. dm value. So can I find out dm value? Yes. dm is equals to, very, very important. dm is equals to, yeah, okay, sir.
Jagdish
Yes,
garu,
sir, okay.
good evening, Jagdish
Just,
garu.
Yeah, good evening, sir. No problem. I will wait 2 minutes. Okay.
okay, sir, okay. Now here, how can we calculate dm value? So this is a disk. So just you have to consider the just area of the disk. So now what is the total mass of the disk? Capital M. Per unit area, I said already. Per unit area. So automatically we get the just dA value. If it is just per unit length, m by L into dx.
Sir, why
Per unit volume, m by V into dV, like that. Okay. So here for unit area, capital M by capital A into dA. Per unit area, just remember this point. So dm is equals to m by just why do you just write A? Why do you write like A? Because of per unit area, what is the elemental mass of the given disk? Sorry, ring. So simply we can write dm is equals to m by, we know the area. Area equal to area of the just ring, like a circle. What is the area of the circle? Pi r square. So simply we can write pi r square, but this is a semicircle by 2. Pi r square by 2 into, here is very important. How can we calculate the dA value? How can we calculate the dA value? So dA is nothing but like side into side. dA is nothing but like a side into side. Just I want to calculate now. Now if you are just stretching this ring path, if you are stretching the ring path, so finally you get the just like straight line. Am I right? This is a straight line. This is a ring. Of width equals to like dy. Of width equal to like dy. Students, this is very important point. Now here this is a stretching ring of width equal to dy. Now tell me what is the circumference of the circle?
2 pi r.
Yes, exactly. But this is half 2 pi r by half of the circle. That means 2 pi r by 2. Now simply we use pi r. R is equals to, I said already, ring pi into y. Pi into y. Is it okay?
Yes, sir.
Now, just how can we calculate the area? Area is nothing but just try to understand. Pi into y into, so dy. So side into side means this is width, this is length. So simply we can write area is equals to dA equals to, we can write pi y into dy. So simply we can write pi y into dy. This is the value of dm value. Please write them, please, everyone. After you write them.
Sir, how did dy come, sir?
Yeah,
Sir, why did you take dy, sir?
dy. dy is nothing but, I said already, this is dy. What about dy? dy is nothing but the width of the ring.
Yes,
So
sir.
this is a stretched ring. This is if you are stretched the ring. This is a stretched ring. If you are stretching the ring, what happens? So this is called width of the ring and the circumference of the semicircular ring. What will get? Pi r. Instead of r, we have to write y.
Yes, sir.
So that's why this how can you calculate the area of the circular ring? Side into side, like pi y into dy. So we got it just a area value, substitute there directly here. So we got it dm value. Directly you can substitute the dm value in this expression, you'll get the answer. Okay, tomorrow I will continue. Up to here, please write them. Just work out the remaining part. Okay, students. We calculated dm value. Okay, na? So already y into dm. Dm value just in terms of y we got it. So that's why just these two terms are similar. So calculation should be very easy. So don't bother about just calculation.
value you got?
Yeah.
How did you find the dA value, sir?
dA value. Just again I said what is the area formula? Like length into breadth. So here width equal how much it is? dy. Length equal how much it is? This is length. Pi into y. So like length into breadth. Pi y into dy. That is the area of this ring. Okay, students.
Nagaraj sir, complete that.
Yeah, complete. Students, please work out at home. Okay, na? Otherwise tomorrow I will explain once again. I gave the just a total structure. Just to simplify the given information answer.
Thank you, Nagaraj garu.
Okay, sir. Thank you, sir. Thank you very much.
Jagdish garu, please, sir.
Yeah, okay, sir. Okay, am I audible to all? I think I'm audible. Yeah.
Yes.
Yes, sir. Yes, sir.
Okay, sir. Okay. So yesterday we discussed about here major terminology, the UPSC system, and trivial names also we discussed here. So majorly yesterday we discussed about the odd roots. So this one already we discussed, and here regarding suffix, and in the suffix also again primary suffix we discussed, and secondary suffix also we discussed here. And third one here, prefix. Prefix also discussed. Again, prefix two types, primary prefix and secondary prefix here. So here primary suffix, first of all, word root means number of carbons present in the longest chain, longest continuous carbon chain. This one already we discussed here, carbon chain. And primary suffix, it indicates the nature of the bond, if it is singular, double or triple, in, in, ein, these are all primary suffixes. And a secondary suffix, it represents the nature of the functional group. Based on the functional group, it will change. And prefix, we already discussed about prefix also. Only cyclo is called primary prefix. I told you in the ring compounds only this prefix is present here, cyclo. And secondary prefix, it represents the side chains or nothing but we can call this is a substituent. So this one also we discussed yesterday. And now today, now we are going to discuss one by one nomenclature of different classes of organic compounds here. So different classes means first of all, I will discuss about alkanes. So alkanes here. Regarding alkanes, so alkanes means nothing but saturated hydrocarbons. Actually here, common name. So common name of alkanes is here nothing but paraffins. So common name is here paraffins here. So para means little affinity, little affinity. That meaning here. So they are less reactive. Paraffins means that means paraffin means little affinity towards the reaction or towards the chemical reagent. And here general formula, I want to say here general formula Cn H2n plus 2 here. Here n value is here 1, 2, 3, 4, etc. And if you see here in this name, what is the primary suffix here? An. So primary suffix is there in alkanes. What is that here? An is the primary suffix here. And IUPAC name is here alkane. IUPAC name of this paraffins is alkane. Here alk is we know common root word for all, and an is the primary suffix. So let us take one example. If you keep n is equal to 1, you can write the formula. If you substitute n is equal to 1, then we are getting formula CH4. Here in the form, this is the formula we have to substitute here. CnH2n plus 2. In the general formula, if I am taking n is equal to 1, then we are getting the formula CH4. So now what is the root word here? One carbon means root word meth, and you have to add this in. Already I told you before. And if you take n is equal to 2, C2H6, then 2 carbons eth, and so primary suffix is common because we are following alkanes general formula. Then for alkanes general formula, we have to write n. We have to add this to the root word. And you can write this C2H6 like 2 carbons continuously, and you can keep 3 hydrogens for each and every carbon. You can write like this also, or you can expand the structure also like this here. We know already. So we can write the structure of ethane like this. So you can do any formula. You use C2H6, you can write, or CH3CH3 condensed formula, or structural formula. Anything we can write here. This is what ethane. And one more, I want to give n is equal to 3. And C3, 8. So 3 carbons prop and N. Okay, propane. So propane, our same formula we can represent like this according to catenation property here. So 3 carbons here, 3 hydrogens, 2 hydrogens, and here 3 hydrogens. So like this also we can. So this is propane, and N is equal to 4 C4H10, because I am using this general formula. Okay, CnH2n plus 2. And how we can say here? Butane. Butane, because but is the root word for 4 carbons. If you are writing these 4 carbons in the straight chain, then 3 carbons. Here 2 hydrogens, 3 hydrogens. So all carbons are present in the straight chain. And if straight chain represents N means straight chain, carbons are present. So N butane also we can write. Why I am writing N-butane here only? Because these 4 carbons we can write like this also. So it is not N-butane. Okay, this is different. So one carbon is acting as a side chain here. Then it is a isobutane. Iso means one side chain in these 4 carbons. So CH3, CH3, H, H3. Again, we will discuss about this. Here, no need here. Just I am telling you, N we have to mention if the carbons are present in the straight chain only, all the carbons. So this is about alkanes. I think you know how to write the structures also. So here that means what here? This is a straight chain alkane. So straight chain alkane, and it is branched chain alkane. This is called here branched chain alkane. We can write here. So this is about 2 types of alkanes here. And next, here we have to discuss about alkyl also. Yesterday I already mentioned this. Alkyl means what? Alkane minus hydrogen. From alkanes, we have to remove one hydrogen. Alkane, general formula what? CnH2n plus 2. So here, how many hydrogens? 2n plus 2 hydrogens. And I am removing one hydrogen. One hydrogen. Then how much we are getting? CnH2n plus 1. That means still one more bond is vacant. Okay, one bond is there here like this. For example, if I am taking methane, methane means formula what? CH4. That's now we discussed here. So carbon with 4 hydrogens. Now I am removing one hydrogen, and removing one hydrogen, then remaining part, this one only, just removing one hydrogen. So the incomplete part, this is called here methyl. Methyl. If you are removing one hydrogen from methane, you are getting methyl. And here there is another substituent has to come. Okay. So this is like a side chain also it can act. Yesterday I told you this one, methyl, how it is coming. Or if you take ethane, what is the formula? Just now we discussed here, C2H6. But I am removing one hydrogen, so C2H5 only I am writing. Now it is called here ethyl. Ethyl. Okay, ethyl. So ethyl means we can write like this here, CH3, H2 only. Still one more bond is vacant. Okay, another substitute has to come here. Substitute. This is incomplete part. So overall common name is here alkyl. Alkyl. And what is the general formula? CnH2n plus 1 only. Because alkanes having 2n plus 2 carbons. But alkyl having 2n plus 1 hydrogens only. Okay. So this is the general formula. General representation of alkyl group is R. Here capital R represents what here? Alkyl group. Alkyl means what? CnH2n plus 1. Okay. I think you got clarity regarding alkyl. Yeah.
Please move back.
Yeah. Okay.
Yes, sir.
Yes. So regarding alkanes and alkyl we discussed now. Now regarding unsaturated and alkenes. So what is the general formula of alkenes? First of all, alkenes. Common name of alkenes is olefins. Olefins. Olefins means here in the Greek word oil forming compounds, nothing but oil forming. So lower members they react with chlorine. Generally, they form oily products. That's why here olefins we are getting here. So here a general formula, if you see here for alkenes, CnH2n, CnH2n. Here n value starting from 2, 3, 4. 1 does not exist because here alkenes means what here? Double bond. Double bond always present in between the two carbons. So minimum two carbons should have the given compound, because between the carbons one double bond is there. So this type of compounds are called alkenes. So minimum two carbons must present in the given. That's why here n value started with 2 here. So here primary suffix what here? In we are getting. So IUPAC name we are taking. IUPAC name is alkene. Alkene. Here in is the primary suffix. Alk is the root word. Now I am taking one example here. If I am I am taking CnH2n. This is the general fall. I am taking n is equal to 2. Minimum value 2. Now here C2H4. C2H4. Now here two carbons are there. First of all, these are alkenes. Alkene means definitely one double bond should be present. So that should be a double bond only. And remaining how many hydrogens required for this carbon? Two hydrogens. For this carbon, two hydrogens. So this is the structure, or you can draw the structure like this also. So this is alkenes. Okay, I think you got clarity. So about alkenes, ethylene. This is called eth. Eth is the root word. Why? It contains two carbon atoms. Root word eth, and ene is the primary suffix ethene. Some common names also present for this. Ethylene also we can say this one. Ethylene is the common name, but ethene is the IUPAC name. This is IUPAC name. So IUPAC name is important. And next, n is equal to 3 if I am taking. Then substitute C3H6. This is the formula of if n is equal to 3, we are substituting. So I am taking 3 carbons in the straight chain. Between any two carbons, there should be a double bond, because this is the general form of alkenes. Definitely there is a double bond is present between any two carbons. Okay, I am keeping here double bond. Now here how many hydrogens here requiring? 3 hydrogens. And here 1 hydrogen, and here 2 hydrogens. So this is what is the IUPAC name here? Alk means root word. Here how many carbons? 1, 2, 3. So prop is the root word, and you have to add the primary suffix in, propene. So like that here we can write for any number, you can take n value, and you can draw the structures also here. And next, another unsaturated compounds are alkynes. So alkynes. So alkynes actually their common names are called acetylenes. These are called here acetylenes because the first member name is acetylene. That's why generally they are called acetylenes. So here they must be contain at least one carbon-carbon triple bond must be present. And the general formula of alkynes is CnH2n minus 2 here. CnH2n minus 2. So here IUPAC name we have to take as alkyne only. Alkyne. This is the primary suffix, and alk is the root word. Ine is the primary suffix here. And here also n value started from minimum 2 carbons, because triple bond should be present between the 2 carbons. So 2, 3, 4, you can take any number. And I'm taking n is equal to 2. And what is the formula we are getting? When you are substituting n value in this formula, C2 and H 2 into 2 minus 2. That means 4 minus 2. So we are getting C2H2. That means 2 carbons are there. Definitely there should be a triple bond, and still it requires one hydrogen this side and one hydrogen this side. So this is the structure. So this common name of this compound is acetylene. But what about IUPAC name? Here 2 carbons. So root word is eth. And what is the primary suffix here? Ine. So ethyne. Acetylene is the common name. Okay, but original IUPAC name is ethyne. According to root word, you have to write. If I am taking n is equal to 4 or n is equal to 3 also you can write. So just I am writing C4 and H 2 into 4 minus 2, 8 minus 2, 6 here. Okay, C4H6. Now I am writing 4 carbons in the straight chain. No problem. You can write any. And you can keep triple bond in any place. No problem. If I am keeping here triple bond. Now 3 hydrogens here. Here no need hydrogens, because carbon already satisfied with 4 bonds. Even third carbon also already carbon satisfied with 4 bonds around. And last carbon containing only 1 bond. So still 3 bonds required. So we are keeping 3 hydrogens. Now this is the structure of C4H6. And how to write IUPAC name? How many carbons here? 1, 2, 3, 4. 4 carbons means root word is but and the primary suffix is I. So butane. Clarity here. So like that here we can draw the structures and we can write the formulas for all kinds. And these are the IUPAC names here. So next another functional group here. And already we discussed a few functional groups. Here haloalkanes. Haloalkanes. So here halo means what here? Halogens. Halogens what? Who are halogens? Already I told you. Fluorine,
Chlorine,
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 bromine.
chlorine, bromine,
So
iodine.
these are halogens. And haloalkanes. Actually, this is the IUPAC name only, haloalkane. But originally, these are called, the common name is alkyl halides. These are called alkyl halides. So here, alkyl halides here. And first of all, in this, different names are there. But we discussed about alkyl halides. And general formula of alkyl halides is RX. Here, RX. R means what? Already I told you. R means nothing but alkyl group. Alkyl group means Cn H2n plus 1 bond. So here R means Cn H2n plus 1 bond X here. X means either fluorine, chlorine or bromine. So this is the general formula for alkyl halides. And IUPAC name. And what is the IUPAC name? Yes, already I told you haloalkanes. Haloalkane. Here, halo is actually secondary. We can take halo as a secondary prefix. Nothing but it is a substituent or side chain we can take. Okay, and so alk is the root word, an is the primary suffix here. Now, let us take one example. If I am taking n value 2 and x is chlorine I am taking, then substitute here. If I am taking halogen chlorine and n value 2, then substitute in this formula C2H5Cl. Okay, C2H5Cl. So now what is the IUPAC name? Already I told you IUPAC name is haloalkane. Here halo means who is halogen? Chlorine. So you have to write chloro. Like halo, you have to write here chloro. And alk is the root word. How many carbons here? 2 carbons. So root word is eth. And ane is the primary suffix here. Ane as usual. So chloroethane. This is called IUPAC name. Okay, IUPAC name. And we can write common name also. Common name also is there. So common name means what here? Simply we can write here. This is ethyl group. Alkyl group is here ethyl chloride. This is a common name. Okay, common name also we can write here. Ethyl chloride. So I am taking one more example I am giving here. If I am taking N is equal to 3 and X is iodine, I am taking halogen iodine. Then how to write here? Yes, you can substitute. So C3, 2n plus 1, 2 into 3 plus 1, 6 plus 1, 7, and X is iodine. So here, IUPAC name, how to write here? Halo. Halo means here iodine, iodo. 3 carbons, prop, ane, iodopropane. And the common name is simply we can write here propyl iodide. This is a common name. Okay, I want to draw the structure here. 3 carbons. 1, 2, 3, and iodine in the last. And here, how many hydrogens required here? CH. Here 2H, CH, H2, H2. Okay, so this is the structure of iodopropane or propyl iodide. Iodopropane is the IUPAC name. Propyl iodide is the common name. So like this here, we can write here. So I think you got clarity here regarding this how to write haloalkanes.
Sir, for
Yeah,
bromine, what is that name, sir?
yeah.
Like,
Bromine means you have to take bromoalkane. Okay. Iodine and chlorine. Fluorine means fluoro. Okay. Chlorine means chloro. Iodine means iodo. Alkanes you have to write here based on the root word. Okay.
sure,
Understood?
sure.
Yeah.
Why we took from n equal to 2, sir?
Yeah, you can take n is equal to 1 also. Just I'm giving example only. Yes, you
Okay.
can take n is equal to 1 here. N is equal to 1 and x is equal to fluorine. If you take what we are getting, CH3F. Yes, you can take fluoromethane, 1 carbon. So methane. Okay.
No, sir. In
Or
alkenes, sir.
you can take methyl fluoride, common name. Okay.
Sir, I'm asking in alkenes, sir.
Because in alkenes, why you are asking? I told you there is a double bond should be present between the two carbons. So minimum two carbons must be present.
Okay.
Okay. Or triple bond must be present between the two carbons means if one carbon, how to exist double bond without another carbon?
Okay.
Okay. That's why. So this is about haloalkanes here. And next one more functional group we are going to discuss now regarding uh, alcohols. This is the general name, alcohols functional group. Alcohols means already I told you, OH group is there in alcohols. And first of all here, this is the general name, alcohols, but IUPAC name very important. IUPAC name is alkanols. Alkanol. And already I told you, whole, it is what here, based on the functional group, it will change. This is a secondary suffix. Yesterday I told you, for alcohol, whole is getting. Ane is what? Primary suffix. Bond nature. Alk is what here? Root word. We know this. Okay. Whole is the secondary suffix. It indicates the functional group. Okay. Now, general formula is here ROH. This is the general form. Here R means what here? Cn H2n plus 1 OH. Cn H2n plus OH here. Clarity. Now, I'm taking one example. N is equal to 1. If I'm taking, then what is the formula we are getting here? Substitute CH3OH. Okay. CHOH. Then how to write IUPAC name? Just see here IUPAC. First of all, alk. Alk means what? Root word. How many carbons here? One carbon. So root word is meth. And remaining part as usual, ANOL, methanol. This is what? Methanol. But there is a common name also is there. Directly we can say methyl alcohol is the common name. Okay, methyl alcohol is the common name. If I am taking N is equal to 2, then what is the formula we are getting? C2H5OH. Here, what is the root word? Two carbons means eth. Remaining part ANOL. AN is primary suffix, OL is the secondary suffix. Now ethanol, but common name is ethyl alcohol is the common name. Generally, in our textbooks, we are getting common names also. We are seeing ethyl alcohol, but IUPAC's name is ethanol. We can expand the structure here because two carbons means according to catenation, you can write like this, and here three hydrogens and here two hydrogens. So CH3, CH2OH also correct. Both are same one. Okay, C2H5OH or CH3CH2OH, both are same. Both are called ethanol or ethyl alcohol. Clarity here. Next, another functional group, ethers. Ethers. What are ethers? So ethers means here, first of all, we have to know the general formula of ethers. Here, ethers general formula is R O R dash. Here R dash, both are alkyl groups only. Both are alkyl only. Here R dash, R dash means Cn H2n plus 1 only. Okay. But either R is equal to R dash or R not equal to R dash. Both is possible. If R is equal to R dash means those are called here generally these are called simple ethers. If both are same, these are called simple ethers. If both are not same, these are called here mixed ethers. And how to write general formula? Okay, general formula means I am expanding. R means CnH2n plus 1, O CnH2n plus 1. Okay, this is the general formula. We can write like this also. And what about IUPAC name? This is important. And IUPAC name is here alkoxy alkane. Alkoxy alkane. Here two root words we are getting. Why two root words in this example? Because these carbons are separated by oxygen here. This is not a continuous carbon chain. This side one a few carbons are there. This side few carbons are there. So these are separated by oxygen. The chain is breaking due to oxygen is present in between them. That's why we have to use two root words. But you can ask one doubt here. If two different number of carbons, then which root word we have to take here? The first alk and second. Here remember alkoxy. The first root word here less number of carbons root word you have to take in the first. And here more number of carbons root word you have to take here. So this is very simple thing you can remember. Less number of carbons you have to write here that root word. The root word having more number of carbons you have to write here alkane. If I am giving one example, if both are same, any place you can write because both are same one. For example, if I am taking CH3O CH3 because I am taking N is equal to 1 in the both cases. In the both alkyl groups, I am substituting N is equal to 1. Both are same. So this is a simple ether. Now you can take this here also root word one carbon means meth. Here also root word meth. So you can keep methoxy in the both alkyl groups having meth only root word methoxy, methane. Easily you can remember. Okay. If I am taking different alkyl groups, because one alkyl group N is equal to 1 I am substituting, another alkyl group I am taking N is equal to 3. So different numbers I am taking. So N is equal to 1 means CH3. On the right side alkyl group N is equal to 3, C3H7. Just I am substituting different numbers. Understood what I am saying? So left side 1 carbon because N is equal to 1 I am taking. Right side 3 carbons because N is equal to 3. So now how to write here? I told you just now. The alkoxy alkane. Alkoxy means less number of carbons root word first we have to write. So here less number of carbons means left side only here is there. So left so here methoxy and more number of carbons means right side. 3 carbons means prop. So propane. Even you can write any side here. Same name only we are getting. You can write like this also, in reverse also, but both are having same because less number of carbons methoxy, more number of carbons propane. We have to write this name only. Any side they can give. Okay. So I think you got clarity here. If different number of carbons both sides, then how to write the IUPAC name? Same type of same number of carbons. That means simple ethers containing both the alkyl groups having same number of carbons and both are same root words. But different root words. Then first part you have to write less number of carbon root word. In the second part, more number of carbon root word you have to write here.
Sir,
Yeah.
what if it is n is equal to 3 and then n is equal to 1, sir?
Anyone, just I wrote here this one only. Same name.
Okay,
Even you
sir.
are taking N is equal to 3 or N is equal to 1, less number of carbons means meth only. You have to write it first root word methoxy only. Okay, na?
Yes, sir.
You can get same name. Even you are writing in the reverse also. According to rule, we are getting methoxypropane only. Okay, because first root word always you should write for less number of carbon root word. Okay, so this is about ethers, simple ethers and mixed ethers. And the next one more important functional group is here, carboxylic acids. So general formula of carboxylic acids is here RCOOH. Here COOH is the functional group. Okay, RCOOH. Here R means what? Here alkyl group CN H2N plus 1 COOH. So this is about alkyl group RCOOH. Now, what is the IUPAC name? How to write IUPAC name? The IUPAC name is here alkanoic acid. Alkanoic acid. Here, this oic acid is nothing but secondary suffix. Okay, oic acid is secondary suffix. Ane is a primary suffix. We know this. And alk is the root word. Alk is the root word. Now, I am giving 1. Actually, here 0 also existing. Why 0 also existed in this compound? For example, if we substitute n value 0, this is the general formula. So here C0, H2 into 0 plus 1, COOH. Actually, this carbon also we have to count because this is continuous carbon with chain. So here C0 means no carbons. H1, so H, CO, OH. So how many carbons in this compound? One carbon. So meth is the root word. And ane is the primary suffix. Oic acid is the secondary suffix. So methanoic acid. Actually, common name also is there. Formic acid is the common name. Formic acid. This is what I am writing first. It is IUPAC name, and it is the common name. And if I am taking n is equal to 1, so then substitute n is equal to 1, CH3, COOH. Is it right? So here, how many carbons continuously? This carbon connected with this carbon also. That's why in COOH, this carbon also you have to count when you're writing the root word because it is the continuous carbon. Okay, additional one carbon is we are getting from the functional group also. So total two carbons means root word is eth. Okay, eth and enoic acid, ethanoic acid. Clarity here, ethanoic acid. But common name is acetic acid. I think you know acetic acid common name. So we can write like this CH3COH. If you want to expand this COH, you have to write like this. Otherwise, directly you can write CH3COH. Ethanoic acid is the IUPAC name and acetic acid is the common name. Clarity here. Any doubt here?
Sir, general common formula for ethers what, sir?
Yes, no, it already I discussed before only. ROR here we discussed. So this is the
No,
general
sir.
formula.
Okay.
Ethers.
No, sir. Common name.
Common name for all not there. Only few. If you want common name, I can say no problem. Here, dialkyl ethers, common name. Okay.
Okay, sir.
If both are same alkyl groups. If are different means alkyl ethers. You have to mention both alkyl groups. Okay. Na? For example, here I want okay, you asked just I am telling. So example, what here? Methyl, methyl, both are methyl groups. So dimethyl ether we can make. Okay, na? Dimethyl ether. But here in the second example, I'm giving different alkyl groups here. One is methyl, another one is what? Propyl. So you have to write methyl, propyl, ether. Okay, this is the common. Okay,
Yes, sir.
yeah. So this is about how to write names for acids here, carboxylic acids. So for carboxylic acids here, mainly you have to remember general formula and IUPAC name. These two are important. So this is the general formula and this is the IUPAC name. These are the major things, not only in this functional group. For any functional group, you have to remember general formula and IUPAC name of that compound here. And next, one more, another functional group here, aldehydes. So aldehydes. So for aldehydes, general formula is here RCHO. Yes, CHO means you have to expand like this. CHO. Sorry, CHO like this. Because carbon valency 4. So hydrogen with single bond, oxygen with double bond. R means what here? CN, H2N plus 1, CHO. Okay. Here also, this carbon also you have to count when you are writing the root word. Because these two are continuous carbons only. And IUPAC name is important. And IUPAC name is here alkanol. AL. AL is the secondary suffix. Okay, AL is the secondary suffix. Here AN is primary suffix. Alk is the root word as usual. Okay. So now I want to give here few examples. Here also we can write n is equal to 0 right? Because n is equal to 0 also exists here. Why n is equal to 0 existing? Because already functional group already containing one carbon. So we can write n is equal to 0 also. If n is equal to 0, we are getting HCHO. So 1 carbon. So we can write methanol. But common name also is there for this. Formaldehyde is the common. So this is IUPAC name and this is a common name. And if
Sir,
I'm
can you
taking
repeat the common name, sir, again?
common name is formaldehyde. This is common name. Common names doesn't have any rules. I told you in the starting, based on the source, based on the process of preparation, they are keeping the names. Those are common names. But IUPAC names definitely, we according to rules only we are writing. If I am taking N is equal to 1, CH3, CHO. Here, how many carbons in the longest chain? 2 carbons. So 2 carbons means eth on all, ethanol. But common name is here acetaldehyde. Common name is here acetaldehyde. Clarity here. So like this here we can write IUPAC names for aldehydes for any number of carbon you can take here. And next year regarding ketones. Another functional group here ketones. So generally ketones general formula if you see here RCOR dash. Here again two alkyl groups, but they are connected with carbon only. Continuation carbon chain is present here. But in the previous ethers, oxygen is breaking the both alkyl groups. But here there is no gap here. Continuous carbon chain only present here. So that means CN H2N plus 1 C double bond O CN H2N plus 1. You can write like this. These two are maybe either same or different. If both alkyl groups are same, then those are called here simple ketones. If both are different, then these are called here mixed ketones. Now here, if I am giving IUPAC name, it is here important here. IUPAC name, if you see here, alkanone. Alkanone here, one is the secondary suffix. It represents the functional group. Here, alk, an, these are as usual. Alk is the root word. An is the primary suffix. On is the secondary suffix here. So overall, this is the IUPAC name. Now I am giving one example here. If for both alkyl groups I am taking N is equal to 1. So here CH3, CO, CH3. Here a continuous carbon chain is present here. So how many carbons? 1, 2, 3. So 3 carbons means what is the root word? Prop, ANONE, propanone, propanone. But common name also is there. This is actual IUPAC name. For this common name also is there. Common name actually it is acetone. Common name is acetone. Or sometimes a few dimethyl ketone also we can call this. Dimethyl ketone because both sides methyl groups are there. So that's why dimethyl ketone. And if I'm taking two different values, one side n value 1, another side n value 2, then how can write here CH3, CO, and here CH2, CH3. This side one value 1, this side n value 2. Now total number of carbons, these are continuous carbon chain only. So total 4 carbons. So 4 carbons means what we can say here? Butanone. Okay. Or we can write one side methyl, one side ethyl group. So we can take ethyl, methyl, ketone. So ketone represents C double bond here. That's why. So this is the common name. We can write like this. Okay, ethyl, methyl, ketone. Any doubt here? So this is about how to write ketones for simple ketones and mixed ketones. And one more functional group here, acid chlorides. Acid chlorides. Here acid chlorides means what is the general formula? Here general formula is here RCOCl. RCOCl. Okay, here R may be either H or any carbons also may be present. That means here n value 0 also existing. That's why I'm telling you here H. because N means here Cn H2n plus 1 COCl. So this is the general formula. And IUPAC name, if you see IUPAC name, yeah, alkanoyl chloride. This is the IUPAC name. Here, oil chloride means secondary suffix here. Oil chloride is the secondary suffix, and alk is the root word, and an is the primary suffix, and oil chloride is the secondary suffix here. Now here, secondary suffix, let us take one example. If I am taking n is equal to 0, then what we are getting? HCOCl. HCOCl. HCOCl means it contains one carbon only. So one carbon means here, what we can write here, meth root word, and remaining part N and oil chloride. Methanoyl chloride. Clarity here. Methanoyl chloride. But common name also is there. Simply we can write here formoyl chloride. So this is IUPAC name. And here formoyl chloride is the common name. So like this here, we can write, if I'm taking n is equal to 1, then what we are getting the formula? CH3COCl. So here two carbons are there in the longest chain. Now here we can write ethanoyl chloride. Ethanoyl chloride. Ethanoyl chloride. So common name is acetyl chloride is the common name. So like this we can write the common names also. So like you can take any value of n and we can write the IUPAC names here. And we know the root words. Already we discussed 1 to 100 root words yesterday. So you can take any n value and you can write the formula. At the same time, based on the number of the carbon atoms in the longest chain, you can write the IUPAC name also. So any doubts here up to here? And few more functional groups are there. In the next class, we will discuss and we will discuss the IUPAC names also again. And few rules are there. Then those also we want to discuss in the
Third
next
one,
class. Okay.
please say alkyl, sir. Alkyl. Yes, sir.
Alkyl. So alkyl means what I told you. In alkyl, we have to remove one hydrogen. Alkanes general formula CnH2n plus 2. So how many hydrogens here? 2n
Yes.
plus 2. From this we have to remove one hydrogen. So what we are getting CH2n plus 1. But you have to keep one bond because we are removing one hydrogen means one position is vacant. Okay. From the carbon we are removing one hydrogen. In place of hydrogen, any other substitute may become. Okay.
Okay,
It has
sir.
so this is this is called alkyl. Clarity.
Yes, sir.
Yeah. Next. So still few more functional groups are there. We can continue tomorrow remaining.
Thank you,
Thank
sir.
you
Bye,
very much,
sir.
sir.
Okay. Ranga sir.
Thank you. Thank you very much, sir.
Okay, sir. Okay. Thank you.
Thank you, my dear children. Tomorrow we will meet again. Thank you. Good night.
continue in top tier.